In this reaction, we're going to take permanganate, MnO4-1, and a peroxide, HO2-, and we're going to turn that into manganate, which is MnO4-2-, as well as oxygen. But also notice that this one claims that it's in base. So in a base system, you have actionable items of hydroxide and water, but you don't have H+ in water, which is what we saw in the acid. So we'll talk here in this section about how to conquer the basic solution redox balancing questions. And it's not too bad. The first way I'm going to show you is actually pretty quick. The second way, which is a little bit longer, is a way that I use honestly quite a bit because I've never felt super good about balancing things in base. But my longer version, my longer process way will work, and it's something just to keep in the mind. Remember, a base could be a pH greater than 7, so I could say balance this reaction in a pH of 8.90, and that would mean balance it in a base. That's totally normal. Okay, so first up is combine the like species. Let's combine the two manganese species as well as the oxygen species. So for the first one, it's peroxide going to oxygen. Peroxide is a special form of a charge on the oxygen. It's a -1. And oxygen is O2 is elemental oxygen. The elements are usually neutral. They don't have positive or negative charges. So we'll put those two together. We'll also put the two manganese together. Now, permanganate, the first one is a +7. We looked at that earlier. But the other one, manganate, if you figure out its charge, oxygen's almost always -2, and there's 4 of them, -8, but it has to have an overall -2 charge. That means that manganese is a +6. So if you look at this long enough, the manganese is going from +7 to +6. It's being reduced. On the other hand, an oxygen that's -1 to an oxygen of 0, that would be something that's being oxidized. Next step, balance each half reaction for mass. The manganese is great. 1 manganese and 4 oxygens on both sides, no problem. But the other one is not balanced. Like, for example, the reactant has an H and HO2-1, and oxygen, of course, has no H. So what you want to do is you want to add water to the hydrogen deficient side. There's like 2 hydrogens per oxygen. And then you want to add hydroxide to the opposite side. So at the end of the day, when you balance this one out, you'll end up with 1 water on the product side and 1 hydroxide on the reactant side. And this leads to a good rule of thumb. If you have a hydrogen deficient side, add water. If you have an oxygen deficient side, i.e. HO2- didn't have as much oxygen as O2 and water, then you add hydroxide. So hydroxide to the side that needs oxygen, water to the side that needs hydrogen. And if that works for you, this method is better. It's quicker, more efficient. But if it doesn't work for you, I'll talk about my alternative method here in a little bit. All right, the next part is to balance the half reactions for charge, and you can only add negative electrons at this point, remember. So for the hydroxide and peroxide side, each of those has a -1 charge, so -2 on the reactant side. And the product side initially has no charge. O2 is neutral, water is neutral, so we don't have any charge. So -2 on the left, 0 on the right, that's not balanced for charge. We can only add negative electrons, so we'll add 2 electrons to the product side, and now the charge will be the same on the reactant and the product side. Both of them will be -2. We'll do something similar with permanganate on the left going to manganate on the right. Manganate is -2 and permanganate is -1. So if we add an electron to there, that's going to make the -1 of the electron and the -1 of the permanganate equal the -2 of the manganate. So that would be the way to balance this out. And again, at this stage, you should have something that's losing electrons and something that's gaining. As long as you do that, you've got this redox system down and you should be good to go. The next step, we want to multiply one or both reactions by some factor in order that we end up canceling out the electrons. You don't want to show electrons in your final reaction. So we'll leave the first part right alone, the hydroxide and peroxide part, but the second one, let's multiply that through by 2. So that would be 2 electrons plus permanganate, and that equals manganate, MnO4 minus 2. Notice there's 2's in front of each of those once again. That's just to make the electrons cancel out. So when all is said and done, you add those half reactions together, the electrons will cancel out. You don't want to show them and stuff. This is what you're going to end with. Peroxide, the HO2 minus thing, plus hydroxide plus 2 permanganate makes oxygen plus water plus 2 manganate. And this is how things flow, if you will, in the basic solutions. If the system we just went through works for you, where you add water to the hydrogen deficient side and hydroxide to the oxygen deficient side when you're balancing basic solutions, you are good to go. However, I've oftentimes had problems trying to figure out how this all works. The hydroxide and water thing is just really weird to me. So an alternate way to balance these reactions, which does work all the time, is you first want to pretend like you're balancing the reaction in acid. And then after you get it all together, you can neutralize the acid with base. And I'll show you what this means here in a little bit. So let's go back to the permanganate and peroxide, the HO2 minus, making manganate, MnO4 2 minus, and oxygen. So as before, we'll separate them out into half reactions. No big surprise there. You want to then make sure that the atoms are balanced on both sides, but we're going to pretend that we're doing it in acid right now. Now, acid's usually really easy, I'll be honest. So what we're going to do is pretend we're in acid, and at the end we will come back and figure out what would be in base. So if this was acid, HO2 minus to O2, well, you can probably see that the reactant side would be just H plus. The manganese you don't have to do anything to, because 1 manganese and 4 oxygens on both sides. But the oxygens, oh goodness, yes. But the oxidized part, the peroxide and oxygen, we have to do something there. And what we would do if this was acid is just add an H plus, because then you see you got 1 H and 2 O's on the reactant side. That makes 2 O's and 1 H on the product side. So the whole process will work. It's a lot easier when it comes to acid. We can just see right away that the product side needs an H plus, add it in, good to go. Next step is to balance the half reactions for charge. We can only add negative electrons at this point. So the peroxide has a -1 charge. The product side is oxygen, which is 0. H is +1 here. And you can see that O2 and H plus, that has an overall +1 charge. And that's a lot different from the -1 on the peroxide on the reactant side. So if you add 2 negative electrons to the product side, now you've got O2 0, H plus and 2 minus, so -2 + 1 is going to give you the same charge you have for HO2 -1. So we're going to add electrons as products in this step. The other one you can make balance by adding an electron to the reactant step. So the product, manganate, MnO4 -2, has a -2 charge, and on the reactant side, the permanganate, MnO4-, that has just a -1 charge. So we need to make the left-hand side more negative. So we're going to add a negative electron to the permanganate. That'll be -1 and -1, or -2, and that's going to be the charge on the MnO4 2-. So we're going to add an electron. Now notice at this point that the peroxide, the first half reaction, that's losing electrons, so that's being oxidized. And the second one down here, the permanganate going to manganate, that thing's actually gaining electrons, so it's being reduced. You don't have to worry about initially if something's being oxidized or reduced. Just kind of put the like species together, follow these steps, and it should come out naturally. We're now going to multiply the half reactions by some factor in order to make sure that when we add them together, the electrons will cancel. So in the oxidized species with the peroxide, you've got 2 electrons as products, but the manganese example only has 1 electron as a reactant. So we need to multiply the permanganate manganate by 2 in order to make sure the electrons will cancel. So we'll have 2 electrons on the reactant side now, and that's going to cancel the 2 electrons on the product side for the HO2- thing. Let's add these half reactions together. The electrons will cancel out. Anyway, you end up then with HO2 minus plus 2 permanganates, and that goes to oxygen gas plus H plus 2 manganates, MnO4 2 minus. And this equation is now balanced, but the pH is for pHs less than 7. So this reaction is balanced for acid. It has H plus. H plus in water means acid, but we wanted our system to be in base, pH greater than 7. So at a pH greater than 7, you'll still have water, but the H plus will be turned into hydroxide. So what we're going to do to make sure this acid reaction is turned into a base, you can add a hydroxide for every H plus that you have. And in addition, if you add something to the product side, you have to add the same amount to the reactant side and vice versa. So in this reaction, as written, there was only one H plus. So we're going to add one hydroxide to both the product side and the reactant side in order to make this all work out. So an H plus OH minus on the product side will be the new thing to look at. And again, you'll also have a hydroxide on the reactant side. If you add it to one side, you have to add it to the other. The H plus and the OH minus will combine to make water. So you can see that down there in the bottom, all of a sudden the water popped in. That's the H plus OH minus. But there's still a hydroxide on the reactant side, because remember, you add it to one side, you have to add it to both sides. So the final reaction, HO2 minus plus 2 permanganate plus hydroxide, goes to oxygen plus water plus 2 manganates. So hopefully it will give you the same reaction as all the balanced ones you've been doing. Just kind of keep this in the back of your mind. So if you follow these rules, you're good to go. I like the neutralize and acid option, truthfully. Once in a while, I don't need to. Once in a while, I can do the base ones on my own. But if you ever need to, it's a pretty cool way to figure this out. Okay, so here's some tips for balancing redox reactions. First of all, you've got to know the pH. pH is less than 7, you can have H plus in water. pH is greater than 7, you can have hydroxide in water. So you've got to know what pH it is to make sure that's going to happen. Acidic pH is H plus in water, basic pH is hydroxide in water. When you're adding things, you never want to add O2, oxygen atoms, oxides, or for that matter, hydrogen, H2 or H plus, H atoms. You just want to add what's appropriate to your pH. So again, pHs that are acidic, H plus in water. pHs that are basic would be water and hydroxide. You want to make sure all the ions have the right charges on them, super important. And again, you can always check yourself at the end to make sure the reactions are balanced for mass and charge. All good chemistry redox reactions will be balanced for mass and